Alright, I'm going to try my best here. This is going to be the 2018 test, FRQ questions 4 and 5. So questions 4 and 5 right here. These are both non-calculator questions. Here we go. This video is just going to be question 4. Questions 3 and 4. Gosh darn it. Okay, questions 3 and 4. This one is going to be question 3. Alright, so the function here is defined from -4 to +8. So we have this little line up here, no big deal. The graph consists of two linear pieces, a semicircle. Let f be defined by this wacky formula right there. Alright, so we begin pretty easy, just find two values. What's f of 7? And f prime of 7. Okay, that's going to be cool. But anyways, let's start off with the f of 7. F of 7, I'm going to put it in this formula right here, just replacing all x's with the number 7. Okay, so we have 21. Now we have the integral on this from 0 to 7. So notice it doesn't go to 8, so it'll be this negative half circle, and then it'll be just the half of this big rectangle, so it'll just be this rectangle right here. Alright, so first is the negative half circle, so that's half pi r, this radius happens to be 3 squared. And then plus the rectangle right here, so that's base of 1, height of 3, 1 times 3. So 21, -9 over 2 pi, and positive 3. So 24 minus 9 over 2 pi. That's the best we can for f of 7. Now f prime. So we got to take the derivative of this. So f prime of x, let's just start there. So derivative of this is going to be 3 plus, okay, so if I take this, a derivative, a d dx, in essence, of, notice how the upper limit is the x, so second fundamental theorem of calculus says that this is just going to, this t is going to become an x. So this is just g of x. Second fundamental theorem of calculus right there. So what this is giving me is, in essence, just literally positions on here. Okay, so the question still remains, what is f prime of 7? So 3 plus g of 7. So g of 7 is literally at a position of 3. So that is 6. So I just have to find the values of f of 7 and f prime of 7. Right there. Okay. Second part of this question, or part B, is find the value x on the interval from -4 which attains a maximum value. Justify your answer. Alright, so maximum value. So what I think of is the first derivative test. I'm looking for like increases to decreases, or I'm looking for critical pieces in general. So f prime is kind of where the whole gist of this, and I'll just steal my answer from up here. That's all right. So all right. So G. All right. So what I kind of immediately look for is critical values or sharp points and things like that. So if I really kind of want to get technical about this, just look at like the weird points from -4 to 3. And so I would kind of look at its endpoints and any sharp corners and whatnots or zeros in between. So I'm just picking out like the usual suspects in this situation. And so, but what I notice here is also all of these g's are either positive or the smallest the g is negative 3. So what I notice is this is a positive number, this is a positive number, this is a 0. So this is going to be greater than or equal to 0 on this realm from negative 4 to 3. Okay, it's greater than or equal to 0. So what that means, kind of like in my brain thought here, is that f, whatever is going to do, is exclusively going uphill. Is exclusively going uphill in the world from negative 4 to 3. So if it's exclusively going uphill, they want to say, hey, where the deuce is a maximum? Well, it's going to be at 3. That's very exclusively where it has to be. If everything is going uphill the entire time, there is no downhill, because all of these values are either positive or slightly negative. Okay? The biggest negative number being negative 3, and that occurs at 3. So it's all positive until it hits that 3, so that means this whole thing has a positive slope. All right, so where is there a maximum value? Well, so all you have to do, so x is equal to 3 is a max. Why? Because f prime of x is greater than 0, or I'll say greater than or equal to 0, for the entire time. On the world of negative 4 to 3. So it's just logical that 3 would have to be the max in that situation. Alright, so C. For each of the limits, so the limit as it goes to 0 from the negative, and the limit as x goes to 0 from the positive of the g primes, find the value or state if it doesn't exist. So g prime is the slope of this. All right, so what is the slope as it approaches this point from the left and from the right? Well, the left is just a straight line, so that one's crazy easy. All I have to do is just figure out the slope of that line. So this first one, the limit as x goes to 0 from the negative side of the g prime, is just the slope. And this has a rise of 2 and a run of 4, so aka 1/2. It's going downhill, negative 1/2 all day long. All right, now this next one is, what is the slope of this circle thing? Well, it's exactly that. It's a circle thing. So the limit as x goes to 0 from the positive. Okay, so in essence, think of this as actually being an actual circle. All right. Okay, so if I want to know, well, what is the derivative, the tangent line? What is the slope of the tangent here? Well, that would be a vertical line. All right? And so what's the slope of a vertical line? Well, that does not exist. That does not exist. It has a rise, but it doesn't have a run. So that would be, something like 1 over 0 or something like that. So that limit, as we go to the positive side, does not exist. Okay. Last but not least, we are going to be looking at question D of this problem number 3. And here we go. Okay. All right. Does everybody smell that? Smells like L'Hopital's rule. Whenever you have like a limit with this big old freaking fraction, I am betting L'Hopital is going to come in here. So that means that the numerator and denominator are both going to be 0, they're both going to be infinity, they're both going to be negative infinity, one of those 3. So I'm dollars to donuts, that's exactly what's going to happen here, and we'll have to L'Hopital this thing. But before we get there, we actually have to show it. So the numerator, we are going to evaluate the limit as x goes to -2, and so that would be f of -2 plus 7. Okay, the f of -2, we have to use this idea right here. So this is going to be 3, -2, 0 to -2, g of t, okay, plus 7. So this is going to be -6. Okay, this is in the reverse order, so that's backwards. So that'll be negative 2 to 0. So -2 to 0 is a triangle. So this is 1/2 base times height. Plus 7. And the numerator will come out to be, so this is -1, -7, what do you know, 0! Well, man, my spidey senses for L'Hopital's are on point thus far. Alright, let's take a look at the denominator. The denominator, limit as x goes to -2 will be e 3 to the x plus 6 minus 1, e to the -6, 0 minus 1, e to the 0, anything to the 0th power is 1, so 1 minus 1, 0. What do you know? Numerator goes to 0, denominator goes to 0. L'Hopital, here we come. Again, apologize for spelling. I don't think really anybody ever even cares, so here we go. L'Hopital means that this limit is going to be equal to the same limit of this derivative. So that would be f prime, 7 goes away. E to the whatever is still e to the whatever. Chain rule down, -1 goes away. Okay, so here we go. So plugging and chugging, this is going to be 3e to the 3, -2 plus 6. That's still to the 0, 1, so this denominator is 3. Okay, f prime, let's take a look. F prime is right here, so that'd be 3 plus the regular g. So this is going to be 3 plus the regular g at -2, which is at 1. And that's going to be 4/3.